Either in line with forces, let's identify the different types of forces. And let's give examples also. So bear with me again. In terms of force, remember that we have to, or when we define force, it's a simple push or pull, right? Whenever you push something or you pull something, you are exerting force on it. It is somehow divided into two groups. It may be a contact force or a non-contact force. So what's the difference between the two? I have here, if I'm going to stretch the rubber band, is this an example of contact force or non-contact force? Like when we pull the rope in opposite direction, and even when we walk or push something. These are somewhat examples of that example of force. In terms of rubber band do have force in it already when you stretch it. Even when you try to pull in different direction, this rope, it is now exerting force. When you walk freely without even sliding, or you can stop from walking, it's because of another force present in between the sole of your shoes and on the ground. Then when you apply force by pushing an object forward or pulling the object backward, there's another force present and for you to be able to do that. So let's find out. Let's start with contact first. From the name itself, it's contact. It is a kind of force that acts when an object makes contact with another object, meaning they will touch by touching. Like when you pull something, you tend to hold it, so you have a direct contact with the other object that you are going to apply force on it. And then when you try to push something, you are also trying to have contact with that object. So we call it contact force. And here are the examples of contact force. One is applied force. This is a kind of force that is being applied by a person directly to the object to make it move. You may be pushing it or pulling the object. So directly, you are applying force on it to make it move. Another is called the frictional force. Friction. It's a force that works against and thus tries to prevent the object from moving. It's the one that opposes the movement of the moving object. That's friction. The reason why we have to consider the type of surface between two objects. The rougher the surface, the greater its frictional force. It will be hard for you to push an object, heavy object, on the ground or on the sand than on tiles, right? So again, you have to consider the surface and friction. The rougher the surface, the greater the frictional force. And there is this special kind of frictional force that happens in the air. We call it the air resistance force. It only happens when the object is traveling through air. So this air force stops the object from falling down or against the pull of gravity. Like this. So when you try to skydive, there is an air that pushes you up, and that is against gravity in some level or point, of course. Another contact force is called the tensional force that only happens to the following materials. Consider the materials: ropes, strings, cables, and other similar materials like them. Whenever you try to pull them in different direction, tensional force is now acting on this rope, strings, or even cables. It is applicable in tug of war, yes, that kind of game. And like this one, they do have, when you hang your clothes, There's already tensional force in this. There you go. Elastic force is a contact force that exerted by when you stretch the rubber band or you try to compress the rubber band and then try to release it, it will return to its original form. That's elasticity, right? And to make this elasticity or to make them elastic, there is a force acting on it. We call it elastic force. And these are some application of the elastic force when you bungee jump also. Then we have the normal force, another contact force acted by the surface in contact with the other object. The object will not move, just stay on the top or surface of another object. That's a normal force. As long as it has its contact with the surface of another object. Another force acting when you cannot really see that they have direct contact with each other. Look at this balloon in the water. How does it act? Without you can see where's the force? Where's the force? Can see it. They don't actually get in touch with each other, but still force is acting on it. And we call that the non-contact forces. Here are examples of non-contact forces, beginning with the gravitational force, wherein it is located at the center of the earth, and it is the kind of force that pulls object downward or towards the center where the gravity is. It also acts between each and every particle in the universe. Gravitation is always attractive and never repulsive like in magnet. Gravitational force is the reason why the moon and the planets of the solar system are kept in their orbits. Now, the galaxies, the clusters, they do have gravitational force in them. The force of gravity does not only exist between our bodies and Earth, it also exists between any two objects anywhere in the universe. In relation to this animation, if there's no air resistance force, the object, whether that's heavy or light, will fall on the ground at the same time if there is no air resistance force. And the ball will move downward because of the gravity present on the earth, moving the ball towards to the center. It is the gravitational force that gives us our weight. So we have a definite mass, it doesn't change. That's the mass of your body or the amount of matter present in your body. The only difference is that you will change your weight whenever you change the location based on the amount of gravity they have. Because weight is equals to the mass of the body and the pull of gravity of a certain place. Another non-contact force is called the magnetic force. This is a force that causes the objects to attract or repel each other, depending on their poles. Same poles, they will somewhat repel, and then different poles will attract each other. Unlike gravitational force, that is always an attractive force. Another non-contact force is called electric force. Electric force is a force that exists between charged particles, positive and negative, much stronger than the gravitational force, and it holds particles together to make up matter. In the forms of lightning, yes, there is electrical force in it. If we combine magnetism or magnetic force and electric force, we're gonna call it electromagnetic force. Again, combination of electric and magnetic fields from the interaction of the different charges or charged particles. The electromagnetic force is more than 1 billion times stronger than gravitational force because it works at an infinite distance. Gravity will only work if the object is near to it, but electromagnetic, it's a different one. The study of electromagnetism led to the discovery of the mass of elementary particles and the invention of some equipment such as television, integrated circuits, which are used in appliances today, like the maglev train. So therefore, those are the things that you need to know about the different types of forces and their examples. Hope you learned something from it. Thank you again for listening and watching.